Bismillahirrahmanirrahim. Welcome to the channel. My name is Asim Amjad, and in this video we continue our problem related to beam bending, but in this case we are now considering the I-beam section rather than a rectangular section. So these are the dimensions of the I-beam. The remaining part of the problem is same as we did in problem number 1. If you didn't solve the problem number 1, then first solve it, then move to problem number 2. In problem number 2, the question is you have to decide as an engineer to change the rectangular cross section to an I-beam shape to reduce the weight of the beam and thereby reduce the amount of material cost as well. That will be called the more efficient design. So if the beam is made of steel with an elastic yield strength of 36 ksi, so what is the maximum moment that the beam can support and remain in the elastic region? So as you see, in this case our beam is not the symmetrical. So for finding the centroid of the unsymmetrical shape, use this formula, that is summation of yi times ai divided by a total. A is the area of the cross section. So let's find the a total. That would be equal to 2 times 10. That would be the area of this first rectangle. Then find the area of this second rectangle, and then find the area of this third rectangle, and the total area would be 78 inch square. For finding the y neutral axis, you have to multiply the area value to its neutral axis distance. So this would be the central axis of this rectangle. So the distance from this point to this point would be the y1. That would be calculated as the total distance is 25 inches minus this upper half of the rectangular cross section that have the dimension value of 1 inches, and the answer would be 24 inches. So here you see the 24 inches for the y value, and then multiply this yi value to the area of this rectangular cross section, that would be 10 times 2. Perform the same procedure for the second rectangle and the third rectangular cross section. For second rectangular cross section, the length of this rectangular cross section from this point to this point would be 21. So half this 21, that would become 12.5, that would be the y2, and multiply its area, that is 21 times 2. And similarly do the same thing for this lower rectangle, that is 1 times 1 would be the y3, and the area is 2 times 7, 2 times 8. Divide this to the total area, that is 78, and the neutral axis would be 13.1 inches. That is indicated here, this blue dash line. So for calculating the area moment of inertia, I am using the parallel axis method. So we know that from the formula, I and A is equal to I standard shapes neutral axis plus A times D square. So first calculate the area moment of this rectangle, then this rectangle, and then this rectangle. So in this first rectangle, the moment of this rectangle is 1 by 12 times base, that is 10 inches, times its height, that is 2 inches, or cube. So this one is the moment of this rectangle. Then find the moment of this rectangle, that is 1 by 12 times 2 times 21, and similarly the moment of this rectangle will be 1 by 12 times 8 times 2 power cube. Now you have to find the AD square. A would be the area of this rectangle, that is 10 times 2. Here you can see 10 times 2. Then area of this rectangle will be 2 times 21, and the area of this third rectangle will be 2 times 8. D stair is the distance from the neutral axis. So this is the central axis of this rectangle and this one is the neutral axis of the whole structure. So you have to find this D1. We know that the distance from this point to this point is 13.1, and we have to actually find the distance from this point to this point. So the total distance at this point to this point would be 24 inches minus this y neutral axis, that is 13.1. Then you come up with this D1 value by using this equation and simply state it. Do the same thing for the rest of the rectangle. So we know that the distance of this point to this point would be 13.1 inches. Simply minus this value to this point distance, that is 12.5, and then whole square. And then for D3 you have to find the distance of this point to this point, and we know that distance of this point to this point is 13.1 and minus this value, that is 1 unit, that is 1 inches, and then whole square, and the final answer would be I for the neutral axis equal to 6290 inch 4. So just to compare problem number 2 with problem number 1, you clearly see the area of this rectangular cross section is 250 inch square and the area of this I-beam cross section is 78 inch square. So you can see 31.2% of the original area would be same. So this I-beam has the lower cross section area as compared to this cross section area. So lot of cost and material would be same by designing the beam in I-beam rather than rectangular cross section. And you also compare the moment area of this rectangular cross section from problem 1 would be 13,020 inch 4, and the moment area of this I cross section is 6,290 inch 4. So you clearly see the 48.3% of the original area of the moment of inertia would be same. So from using the Fletcher formula, we know that sigma max is equal to mc or I, and in this problem we have to find the maximum moment. So m max is equal to sigma max time I divided by c. So substituting all the values that we calculate in above, the I is 6,290 inch 4 and the c is the distance from its neutral axis would be 13.1 inches, and sigma max value is given in the problem, and we know that the sigma for steel strength is 36 TSI. So after solving this term you would find the m max equal to 17,300 inch K, and that would be the answer. Thank you.